Hello and welcome back to a new video here on the Boundless 2D video series on the Lötwig Fusel channel. Now in the last video we talked a bit about how all of this module and version of control and stuff works, and in today's video we want to start implementing that. Well, we need to do a few things before we can implement it, because currently if we are doing our mocks in it to initialize our project, it can do a few things that are important, like getting external dependencies, creating projects. But when we open up our Boundless 2D solution, we're gonna notice that the layout of our project is actually very simple, and actually, well, too simple for our purposes, because now currently, if I move it in, we just have one solution. And in that solution, we have one project, which is not what we want because, well, this is not how we want it. We want to have modules, we want to have implementations, and we kind of like want to mimic our inversion of control flow. Everything that we had in a version of control, this is basically what we also want to represent here in our solution. So how do we do that? Well, we need to modify our build system. So what we're going to do is we're going to go into mocks.lua and we're going to start fiddling around with the configuration. So currently you can see that we are using a flat architecture. I want to set this architecture to manual because now I want to basically make sure that I can have the option to configure everything how I want it and not like how MoxPP thinks it's good, which is of course also me because I've implemented that, but I have implemented that not for inversion of control and not for any kind of like fancy stuff that's going on. I have implemented that for a simple project. However, it of course has the options to make it a bit more complicated. So what we can do is we can now implement this function here that's currently commented out, that one. The CMOX function include projects, because this function shall now be responsible of including the projects that we want to add to our build. Now, what we're going to do is we're actually going to write a bit of more code in here. We're not going to do this straightforward. So basically what I want to do is I want to implement multiple things. Now, the first thing that I want to do is I want to have a bit of common code. Now, the common code is going to be the IoC infrastructure, which is kind of like the util project. Let's call this one util. So system utils that are always going to be in there, that are like non-operating system dependent, that don't have anything special on it. So basically a common util project. We might gonna also have a config project. That's not something that we're gonna have just yet because we are not generating configurations based on the system, but that's something that I want to have in the future as well. A configuration project would include macros like which external dependencies are available, which modules are compiled, and a bit of metadata, when was the project compiled, and all of like a bit of infrastructure configuration stuff that kind of like give us a bit of an information on the current build environment in the whole project, for the whole project. Now this is kind of like the common code. We're gonna have util config, and what I also gonna have is I'm gonna have my API sets. These are also gonna be in my common code. Now after we have our common code, we're gonna have our modules, the actual implementations. Now I am just gonna template these with a quick something like that to comment this out. So what we're gonna have is at some point modules. So we're gonna include modules, and when we have modules included, we kind of like have some pieces of code that use our common code, our standard library, if you want to call it like that, like configuration, the API set, and the actual util code that is shared across everything. We then use these in the modules to implement these APIs. Now, the modules itself, they actually need to be registered within the common code, so maybe we actually want to swap these later on. Oh, I didn't want to close these. This might be something that we want to swap later on, that the modules are kind of like compiled first, or not compiled first, because compiling is always dependent on the dependency chain, but the build system maybe shall run the modules first. This is something that we might want to consider, that we have the modules first, so that all dependencies can be resolved, because this is kind of like static, right? The common code, we always going to have util, config, and API that the modules can rely on. However, inside of the config project, we might need to rely on which modules has been included, has been properly included, and are active on the current platform, so that we can generate our configuration and we know how modules are generated, something like that. So this is something that we might want to take into account to do it like that. After that, we're gonna have our applications. We're gonna have our applications divided into tools. So we're gonna have some tool projects that we want to include, and later on when we have our tools, we have our apps. So what are apps actually? Apps are kind of like the games. So We could call this one games so that we have kind of like a game directory, but I wanna maybe put them all together in one big application section. We can later on split them if it's getting a bit out of hand. Now, after the modules, what I want to actually do is I want to group these. If you're grouping these, they are getting dedicated folders in Visual Studio. So we're going to have some modules. And we're going to have a common group for our common code. And we're going to have a group for our applications. Let's call this group app for now. Now, as you can see, currently, this should be commented out as well. This is not going to do many things. If I run that with mocks in it, we're not going to have some stuff. Actually, you can see that we're having a problem even generating a solution. We have the problem generating the solution because Premake can't really deal with empty solutions where nothing is located in. Now, how can we solve that? Well, basically, we need to modify a bit on our directory. And I do have something in here that I've tried out a bit. Let me quickly delete this so that we are on the state of what we had last video. Basically, this is what we had last video. We had a dummy project in here with build.lua and domain.cpp and a generated project. Now, what I want to do is I want to divide them into new folders. We're going to have a common folder. So for all common code, we have a folder called modules for all of our engine modules. And we're going to have a folder called app for all of our applications. A dummy is an application. So I actually want to move dummy up to app. You can see currently this is using my MoxP default syntax. We're going to change that in the future. Now this is just a bit of a reworking of the layout. Now we need to make sure that these layouts are considered. How can we consider these layouts? Well, we need to modify the build system or the function inside of the build system here. And I'm going to modify this function by basically stealing code from MoxPP. So currently in the scripts directory we have like libmux and and premake5.lua. Premake5.lua is being the base file for including the project, and libmux as a library for defining all of these template functions that we basically implemented. There are a few fancy things in here that happening in libmux. However, what we currently care is premake5.lua, because basically premake5.lua is loading the projects depending on the configuration. So if we have single, it's doing basically that code and just includes one build.lua. If we have flat, it basically iterates flat. And if we have hierarchical, it iterates hierarchical. And if we have manual, it calls our function, which is what we are currently doing. Now, what we kind of like want to do is we want to do multiple flat build or multiple flat architecture. So we want to have a flat hierarchy for our apps, and we want to have a flat hierarchy for common, and we want to have a flat hierarchy for modules. We could actually have this completely set as hierarchical, but the problem if it is hierarchical is that it discovers the subfolders automatically. If it discovers the subfolders automatically, it has a problem because it starts at app, then it goes to common, and then it goes to module. However, everything is dependent on the modules, and they want to first iterate through all modules so that they have the chance to set up a Lua global state that we then can later on consume, so that we kind of like know as soon as we're building common and app which modules are currently included. Now, how can we do that? Basically, I want to just copy that code from the flat hierarchy, and I want to paste it in here. So this is basically what I want to do. So for directory in discover subfolders, add one directory up, because we are relative to the current execution of the premake5.lua file, which no, we were inside of the script directories. Now we are in the root directory, so we don't need to go up here. It was inside of the scripts. In the scripts directory, we need to go one up. However, down here, I basically want to go down to source, and inside of source, I want to go to modules. So this is kind of like the idea. I'm going to go inside of the module directory, and then I'm basically requiring to build a path out of these, which is basically that, modules in the directory that we have discovered, and then we can have a project file, and if this is a file, we can include this. So this shall basically discover all modules, and basically what I want to do is I want to have the same code for common, and I want to have the same code for app. And as you can see, this is kind of like bad because we are copy and pasting all the way around. So we should do a library function for that. So let's create a new file and let's call this boundless2d.lua. So we are adding a new Lua file, and we have project this covery functions, and then we do bl2d include folder name function. We need a function keyword for Lua, and then we can paste in this code, and we can change the include path. Now again, now we need to go one up, and then I go into the name directory. So something like that, modules name, and then I think this should be good. Now we can call that inside of our mox.lua here. We can call that for modules. We can call this for common, and we can call this for app. I think I have called this one. Yeah, it's singular. Modules. Okay, but common. Yeah, let's keep modules as plurals and the other ones not. So this code should nearly work, I think. The only thing that's missing is the actual include. So what we need to do is we need to include the function. We might actually, since we are using this as a function, we might not need this like that. We might need it like that. So let's include scripts. And let's include boundless2d.lua. And now this hopefully shall already work, if I didn't make an issue. Okay, it has not been able to open this up. Okay, so okay, yeah, I know what the problem is, because this is actually a function, and if it's a function, it's relative to the other directory, so I need to go to up to go through it, because basically we're calling this from premake.lua, and premake5.lua is inside the scripts directory, so we need to go one directory. Alright, so now you can see it has generated that. It looks good. It has generated something, and now let's open up the solution file, boundless2d.sln, and let's see how the layout is now. And now, yeah, you can already see it. We have an app directory and we have a dummy project in the app directory. And that's exactly what I want. This is already giving us a bit of structure. It's not enough structure actually, because we need to do a few more things. Basically what I am currently doing is that inside of application I'm doing like mox project, mox CPP, mox console. This is all something that I don't want to have in here, because this is something that shall not be controlled by the application. The application should just be a boundless2d application. That's the only thing, a BL2D app. And this is the thing that we want to do, a boundless2D application. That's it. Nothing more than that, just a application, not a project, not CPP, not console. This is all something that shall be set up by the build system automatically. So we're going to go into our library functions, and we're going to create like project template functions. Template functions, there you go. So what we want to do is basically have a project here, so BL2D as a prefix, and then I'm going to say application. This is one function that we're going to have, and an application is going to get a name. So we have multiple projects here actually. We're going to have a BL2D application. We have a BL2D lib for a library that's going to go into common. And what we're also going to have is a BL2D module. Okay. BL2D module name. So that's the basic idea that I want to have. I basically want to have the option to create a library, module, and application. Actually, library, I even want to specify even more. Maybe, I think it's okay. Maybe we do add another one like BL2D headers. So we have now header-only stuff, we have library stuff, and we have a module and an application. And the general idea is that this build.lua, instead of calling these premake moxibyte functions, functions, I basically just say that I have a dummy application, which is a simple demo app for testing testing the toolchain. So general idea of the dummy application, I think actually that I want to keep the dummy application because it's a quicker thing to check if everything builds without even having features. The dummy application shall just construct and destruct the engine without doing any drawing and stuff like that, so that we can quickly verify that all of the systems are correctly initialized. And basically what we are currently doing is we are currently doing that inside of here, and what we want to do is we want to make this one go inside this template function, so application. So the application shall create a new project, set it to C++, and define it as, for example, a console application. However, I'm not sure if I want to always have it as a console application, because that's not good. Actually, I want to only have it as a console application if the configuration is in a debug configuration, right? Everything that shall be shipped should not be a console app. What should be a console app? If we take a look at our configuration, debug. These two debug configurations shall definitely be a console application, so that we have a debug console there where you can see what's going on. But development and development editor as well as release, they shall not have a console, right? If we are on development and the developer is working with the game developer is working with the engine, not me as a programmer, they shall not have a console, right? They should just have a UI for the editor that pops up and they can go in here and fiddle around with it. No console required. Same goes for release, of course. If we are releasing, we don't want to have any console, right? If you're on Steam and you're opening up a game, you're not going to get console, right? It's directly going to open up a window and everything is good. And that's what we want to mimic here as well. So only debug and debug editor shall have a console. Now, how can we adapt these? Well, we can take a look at how libmox is doing it. Libmox is doing things with filters, and you can see that's actually defining filters on the configurations and then defining the macros and stuff. So we basically need this configurations filter here inside of our boilerplate code as well. So console shall only be on configuration debug or debug editor. This is, I think, the correct way of doing it. I'm thinking this was with the keyword. Not 100% sure though, but we're going to find it out. And then we're going to copy and paste this one so that we can define the thing, not debug and not debug editor. I think this is the syntax that should work. So if we are on debug or debug editor, so we're going to define mox console. And otherwise, we're going to define mox windowed. Windowed basically means no console. And this now already gives us a bit of control over the console. So setup, console, or Windows app. Or let's windowed app. Let's define it like that. On Linux, this is actually not even affecting something. This is just Windows stuff. Now, what we also want to do, if we are having an application, we want to consume common and modules. So we want to consume everything that's inside of our common code, and we want to consume everything that's inside of our modules code. That's something important that we want to do. And this is basic setup. Now, how do we consume common and how do we consume modules? Well, we can only consume them if they have been produced. So let's actually start by providing some boilerplate code for these. And now you can see that actually this basic setup is something that I would have copied over to everything, which is not good. I don't want to copy stuff. So function BL2D project. Now I gotta have a BL2D project function, and the project function shall always do my basic setup. Right, this shall always configure the default ones, and we might just in here, and we might later on define a bit more information on what this is doing. Maybe we are gonna having a few macros in here set and stuff like that, so we can always put this into the project one, and this is gonna be available for all kind of projects. Now, the only difference here between like a library and a module is how we are going to output these. Now these were like windowed, and what I want to do is I want to have there as a static library. So modules are gonna be always static libraries. Libraries are always going to be static libraries, and headers are going to be, I think is there a mocks header only? I think there is a mocks none. It's always good if you don't know your own code base. I think there is a static lib none, and I think none is like header only. Also, I know that none is header only, but I wasn't quite sure if I might have a custom command for that, but it seems like that I don't have. So let's add that one in here. So we are none and static lib. This is kind of like the configuration. Let's call this one build type, because it's kind of like the type of build that we are doing. Or maybe project type. And I do want to have a bit of a standardized syntax in here. So we have the project type. And now what we basically need to do is we basically now need to produce lib. So we want to produce a library here. And down in here, we want to produce module. So how can I produce modules and libraries? Well, it's actually not even that hard how we can produce them. We just need a global array that kind of like gets filled. Now global arrays can be defined somewhere above here. So global. Global is, I think, a keyword in Lua. I'm not quite sure if I have used that in stuff. So actually in the dependencies folder, if you're taking a look how the Conan utils, how Conan dabs.premic5.lua works, they are actually working in a quite similar way. Actually, I think it's working here because there's a destination and source, and it's always merging them in here. Okay, if Conan depth equals nil, then Conan depth. Okay, so they're initializing them like that. We could also do it like that to initialize the global array. But I think we want to do it. We want to do it a bit more straightforward. Have I not used that in mocks pp? Did I not use globals at all? I mean, in general, right? Like, all of these are globals in Lua. So we don't need the keyword, the global keyword. But I do want to have it as a prefix, right? I'm going to say global dependencies, or let's call it... Do I just want to make the macro style like on a preprocessor? Maybe. Let's call this one then build commons, because it's kind of like a plural, and build modules. So we have modules and commons, and what we want to do is we want to append to these. And appending to an array in Lua isn't that straightforward actually, which is why I have done these here. Kind of pre-make t-merge table. If type value is table. There is a bit of things going on here. Maybe in pair source. Let's quickly find out how we can append to an array in Lua. Not a problem. Quickly searching that Lua append to table, because in Lua everything is like a table. There is like, I think, a way to append to that. Table.insert. I think this one should work like the same like that. Let's see if table insert works with the table name as foo and then as bar. So if we are producing a library, which is actually like a common lib, but we only append to like common. Maybe let's not call this common, let's call this build libs, because actually common can be header only and common can be library. So let's call this build libs and build common and build modules. So I want to insert into that, and I want to insert the name to that. So that's the kind of like idea. And later on we try to consume these. How do I gonna fake the consumption currently? I am just gonna... I don't think that I have print recursive, because I can't print tables, right, in Lua. There's no like print recursive like PHP, which is a bit of a pity. There's like a function for that. However, we can we can print the build modules. I think we're not currently producing any libraries, so we're not gonna even see stuff there currently. But we could quickly check if the code runs without problems. And it runs without problems, that's already good, which means that the syntax is at least correct. If it works at runtime, that's a different story. But that's a general idea, right? So how do we consume modules? So basically what we want to do is we want to iterate over these. So I think for that I can consider my library code that I just had. Basically this for KV in pairs do. That's what I want to add in here. Or actually I don't even need that. I can directly say links and directly link to the libs and modules. Can actually do that like that. Libs and modules, we can directly link against these into calls. And if they are empty, this shouldn't be a problem, I think. Yeah, it's not a problem. But I would recommend doing it like that. Maybe we're gonna change it in the future, but for now I think this is fine. There is now the question if it works. Now we can do it by adding a new common library. Now I'm gonna have the common library BL to the IoC. Oh no, actually I don't think that I need these because like there's this directory common and I think I can go via the include path with common. I am a bit concerned about my include path currently. Maybe we want to add a new folder quickly in here and call this BL2D for boundless2D. And maybe we want to move all of our code into the BL2D directory. Of course, you move that folder out of that. And then let's move this into app again, which of course requires us to change a bit of our scripting because I do want to have a bit of include paths set up differently in the future. So mocks.lua shall now point to modules, so BL2D modules, BL2D common and BL2D app, which should make that work. And then we can quickly add a common library. So now I can name this like IoC, because now the library is going to be called IoC for inversion of control. And it's going to automatically include itself, right? That's the general idea. Then I can create my build.lua file. I can create my dummy.cpp so that it compiles to a module. And then I think in app, I am currently using like this BL2D application. And in IoC, I want to say inversion of control or inversion of control infrastructure and call this one IoC. But of course, it's not an application, right? Now it is actually a library. BL2D application, and then we have a library IoC. And I think if I made everything correct, this should now automatically link itself together. All right, you can see that we have generated IoC and dummy. And if I open the solution up, I would think that I have a common directory, and in my common directory, I'm gonna have the IoC container. And in my app container, in my app directory, I have my dummy. And in general, the app, if I build that one, it should build IoC if everything is correct. Yeah, it built IoC, and it built a dummy. And then it generates, or should generate a exe. What? Invoke main. Unresolved external symbol. win main. Okay, so there's something not working. On debug, this should actually work, because on debug... Okay, so something is wrong with our code inside of here. Currently, on debug or debug editor, it should set console. And this didn't work. It tried to do windowed. So it probably, if I print something in here, if I print name and I print console, and if I print name and I print windowed, I think we should get both. If I run that, you can see that it detected console and windowed. This is not good. Debug or debug editor. And not debug and not the... Okay, maybe is not debug and it's not debug editor. However, this is true. I mean, like, this debug is currently true and this is false. So we have false and true, which should in theory be false. Or can we do it like that? I think I already had a bit of problems with these because I think and might not be a thing in the... Is and? I don't know. How do filters work in Premic? Let's quickly maybe see keywords. How do they work? Configurations, debug. This or that. Like, this is what we had. Debug or editor. This works. And I think not also works, but maybe you can also use not to apply the settings to all environments where the identifier is not set. I'm not quite sure if that works for configurations, but I think it should, right? Not debug and not debug editor, but it doesn't work. Maybe we can add brackets here. I'm not quite sure how this works. If this works from the syntax of Conan of Premic 5, it kind of works, but it also not work. It's interesting. Windows or configurations not debug and configurations not debug editor. Maybe something like that works. I mean, Premic is a bit problematic from the logic. Invalid field prefix debug and configurations. Yeah, it seems like that this and is a bit of a problem. But no, there is a bracket. That's wrong. Not quite sure how they are actually evaluating that. I mean, console is still like working, it's okay. Invalid field, prefix, debug, and configurations. Debug and configurations is currently resulting in a problem. Debug and configurations. If I would say or not debug or not debug editor, which of course would not work, but I think that one is, if I'm correct, should then work, right? Yeah. Okay. But this is a problem. So can I not do it differently? It's a bit sad that it doesn't work. Like not debug would work, but it's kind of like doesn't work chaining these, right? So we could hardcode them for now. Is there a filter else? I don't think so. I don't think there is actually, but it would be nice. Maybe we can use wildcard. If I say debug star and configuration is not debug star, maybe this works, right? Let's try it out quickly. Which gave us... I'm a bit of an idiot. I can't do this with print because it's of course gonna do it printed multiple times because it's evaluating it multiple times. It's doing internal states. I'm not good. But this might work in a solution. Of course it works multiple times because I'm running it for all configurations. I have made a mistake there. Premic 5 executes the code always. It's just a function filters. It's not like a real if switch. It's just modifying the internal state, so it's always gonna do it. But if I rebuild this now, does it compile? Yeah, 2 succeeded. So this worked. Dummy.exe now works. I can verify that by going in here. You can see that it is a where was it? Advanced linker system, I think. Console. Yeah, it's console debug. Debug editor is console. development is Windows, Windows, Windows. Okay, so this works. That's nice. So that is all set it up correctly. And I think this shall conclude today's video. We have made, well, maybe one thing. I want to do one more thing. I just want to have a template module. So that we are kind of like feature complete. So let's quickly add a new folder here. I wanted to kind of like name my modules like Java or C# packages. bl2d.dummy is the module that I quickly want to do here. Build.lua and maybe a dummy.cpp as well. Build.lua is basically going to be that one. No, this is the CPP file. The dummy.lua is basically going to be a dummy module, and it's called bl2d.dummy. And this is going to be a module. And let's quickly run this and see that this also works. And you can see where we get generated that, and instead of here for reload, we should get the modules directory, and we get the bl2d dummy module, which is good. And if I compile my dummy again, I hope that both of these compiled. Yeah, dummy and IoC was compiled, and then the exe has compiled. So the path is also correct. We do have to do a bit more fiddling with the project system, of course, but for now I think this should be sufficient. Let's make a commit and call this changed build system. Right. Alright, save all and commit changes. Yeah, and that's it for today's video. In the next video, we're going to implement the inversion of control itself. So thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.